So welcome back. 10.5, we're going to be introducing slant asymptotes, which are what we get when we have top-heavy graphs. So instead of being straight vertical or straight horizontal, we're going to actually have asymptotes that are at a slant or at a diagonal. So we're going to start with number 1 here, where finding our domain, we find that before we simplify. So looking at my denominator, 2 and negative 2 will make it 0. So I'm going to have negative infinity to negative 2 in union with negative 2 to 2 in union with 2 to infinity. Did not leave myself enough of a line there to fix that. Now, but for vertical asymptotes, we want to reduce first. So when I look at my fraction, I notice that I can reduce the x minus 2's. And so what that means is that at x equals 2, we're going to have a hole in our graph, because it's still not part of our domain even though it's simplified away. So it's not an asymptote, it's a hole. So let's see. Our vertical asymptote would then just be x equals negative 2. So I'm going to go to negative 2. I'm just going to put 2 on my graph here so I remember later. And this is going to be an asymptote. My limit as x goes to infinity let's see. We'll have 3x plus 1 over x plus 2. The degrees are the same here, so our horizontal asymptotes, the ratio of the two, so 3 over 1. So I'm going to go up to 3. X-intercepts, we set y equal to 0. So we'll have 3x plus 1 times x minus 2. Actually, we won't have x minus 2 because that went away. That canceled out. So when we solve this, we get x is equal to negative 1/3. So I know over here at negative 1/3, I'm going to have an x-intercept. For our y-intercept, we set x equal to 0. So when we set y equal to 0, or sorry, x equal to 0, 3 times 0 plus 1 over 0 plus 2, you get 1/2. So I know that 0, 1/2 will be my y-intercept. I'm going to put 1/2 there. And so at this point, I have all my information in order to be able to graph. So I again look at my multiplicity at my asymptote. That was a 1, so this is odd. So I have an odd asymptote. Since I need to go through these 2 points, this one I know is going to go something like this. But when I get to about where 2 would be, I have to remember to put an open circle. So I have my hole. That would account for what I just canceled in the simplifying. Since it's odd, it has to go in opposite directions. So my other graph will be up there in that top corner. So this one was really similar to the ones we did in 10.4. The main difference was this one we had something simplify, giving us a hole. And really that was the only real difference. So once you've done your domain and you simplify, you can use that simplified equation to help you with your vertical asymptotes, your horizontal asymptotes, and your intercepts. You don't have to keep going back to that big one that you started with after you've reduced it. Okay, so number 2, because we are going to do a second one here, this one is going to be a top-heavy. So this is going to be an example of what do we do when we don't have a horizontal asymptote. So we're going to start the same way, finding our domain before we simplify anything, or even try to simplify. So our domain, let's see, that's -1. So negative infinity to -1 in union with -1 to infinity. For our vertical asymptotes, so if I try simplifying the top, nothing will cancel, so I can still have my vertical asymptote at x equals -1. I'm going to go ahead and sketch that since I have it. Now my horizontal asymptote. My limit as x goes to infinity of x squared minus x over x plus 1. It's top heavy, so it does not exist. So that means we do not have a horizontal asymptote. When you don't have a horizontal asymptote, you have to check for a slant. You'll never have both a slant asymptote and a horizontal. You'll only have one or the other. So you only have to do slant asymptotes when your horizontal is none. So how do you find the slant asymptote? You divide. So in order to find your slant asymptote, we are going to divide x plus 1 into x squared minus x. So again, if you can, if it's in the right form and you can use synthetic, feel free to do so. I'm going to do long division here just because we tend to have to do it more often with these. Plus x, and then we subtract. We get -2x. There's nothing to bring down, so I'm just going to bring down a 0. So then we have -2. And so we get -2x minus 2. We subtract, and we get a remainder of 2. So when you're doing this, your slant asymptote is this line right here. It doesn't matter if you have a remainder or not. Your slant asymptote is just going to be the linear part that's in your numerator, or that's up in your divisor. So slant asymptote is the equation y equals x minus 2. So we have to graph this line, so down 2, and then our slope is 1, so up 1 over 1, up 1 over 1. That would put us at 2. Yeah. So here we'll have our slant asymptote. So when it comes to sketching this graph, we can still find our x-intercepts and our y-intercepts, just like we did before. So our x-intercept, we set y equal to 0, x squared minus x, so x times x minus 1, we'd get 0 and 1. So 0, 0, and 1, 0. For the y-intercept, we kind of already found it. Since it goes through 0, 0, your y-intercept is also 0, 0. But you can go through the work of it too if you want by plugging 0 in for x. So now we have enough information to sketch our graph. So we still have to look at our multiplicity. So at our vertical asymptote, this was an odd multiplicity, so we do still have to go in opposite directions at our vertical asymptote. Since I have to go through these 2 points, that's telling me that I'm going to have something that looks kind of like this. So again, instead of being able to go horizontally at an asymptote, we just have to slant back up. And then opposite means this one has to go something like that in the bottom. Okay, so it's again very similar to the horizontal. It's just whenever we have none for horizontal, we're going to most likely have a slant, which is just a line that we can find by dividing our fraction. Most of the time we end up using long division just because we don't always have it in the right form. But this one, if you wanted to do synthetic, you could. You would just need to remember to put that 0 placeholder in at the very end so that you can get your full expression. So again, we are going to do a couple more graphs that are top heavy, actually just one more graph that's top heavy, so that you can get an idea about slant asymptotes and how to graph them with slant asymptotes. So again, come with questions if you have them.